1, 2, ready, go. 1, 1, 3, 1, 2, 3, 4. 1 and 2 and 3 and 4 and 1 E and a 2 E and a 3 E and a 4 E and a 1, 1, 3, 1, 2, 3, 4. 1 and 2 and 3 and 4 and 1 E and a 2 E and a 3 E and a 4 E and a. Good morning, scholars. Your turn. All right, today we're going to be continuing on with our Math in Music series, and we're going to be turning these rhythms into decimals. Rhythm into decimals. So let's go ahead and get started. All right, let's review. Remember that a half note is literally half of a whole, so it gets 2 beats. A quarter note, it takes 4 of those to equal 1 whole measure, right? Because there's equal to 1 beat, and so we're in 4/4 time, so it takes 4 of those to equal 1 whole measure. All right, so an eighth note pair, remember it equals 2 notes in 1 beat, or 2 sounds in 1 beat. So it is 2 of these to equal 1, okay? And then our 16th notes, remember we need 4 16th notes to equal 1 beat. And there are 4 notes or 4 sounds in 1 beat. Great, I'm glad you reviewed that. Let's go ahead and get started on turning those notes into decimals. All right, so I have a half note here. So if I write it out in fraction form, 1 half note looks like that, 1/2. If I have a quarter note right here, it's 1 quarter note, and I know it takes 4. So 1 quarter note looks like 1/4, or 1/4. All right, 1/8 note looks like this, 1/8. 1/16 note looks like this, 1/16. All right, remember that the top part of the fraction is called the numerator, and the bottom part is called the denominator. Okie dokie. To get our rhythm into decimals, today we're going to be using long division. Everybody say that, long division. Great. So we're going to be using long division to get these into decimals. How do we do that, Miss Stone? Guess what? I'm going to show you. All right, so let's start with step number 1. You take the numerator and you put it right here. And we're going to make our numerator into a decimal form already. So here's 1. And now we're going to add a 0 after the decimal, because that 0 is nothing. It still equals 1. But now I'm showing 1 in decimal form. Okay? So I've got 1 in my decimal form. That is my numerator. Now I'm going to take my numerator and divide it by the denominator. And the denominator is 2. Okay, so here we go. Get ready. I need to see how many times can 2 fit into 1. Well, guess what? 1 is smaller than 2, so 2 cannot fit into 1. It fits in there 0 times. 0 times 2 is 0. So I'm going to put it right here under the 1. And then subtract 1 minus 0. 1 minus 0 is 0. And then I have this extra 0 here. So I'm going to go ahead. Miss Stone is so wrong. 1 minus 0 is not 0. 1 minus 0, 1 minus nothing is still 1. They get it together, Miss Stone. Yes, let's hope Miss Stone can get it together. Okay, my bad. 1 minus 0 is 1. Okay, And then I need to bring this 0 down. Oh, I forgot an important step. I should have put a decimal right after my 0 to hold its place in my answer, okay? Don't forget that part. Okay, so how many times can 2 fit into 10? Well, if I do my multiplication, it'll help me. So 2 times 1 is 2. 2 times 2 is 4. It can still fit some more times. Let's see, 2 times 3, is that 10 yet? Nope, that's 6. What about 2 times 4? That's not 10 yet, that's 8. What about 2 times 5? Whoa, there we go, 2 times 5, write it right here. 2 times 5 is 10. So it can definitely fit into 10. So 2 times 5 is 10. And then I subtract. 10 minus 10 gives me nothing. I'm left with 0. So this is what 1/2 looks like in 2 decimal form. Okay, let's move on to our quarter note. I'm going to take the numerator, 1, turn it into decimal form, 1.0. And then I'm going to divide the numerator by the denominator, 4. How many times can 4 fit into 1? 0 times. Add my decimal to hold its place in my answer. 0 times 4 is 0. 1 minus 0 is 1. Bring that 0 down. Can 4 fit into 10? It sure can. Let's see how many times. So 4 times 1, 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. Oop, that's too many. So let's go ahead and use 4 times 2 because 4 can go into 10 2 times. 2 times 4 is 8. 10 minus 8, well, that is 2. We add a 0 up here, and we bring it down. How many times can 4 go into 20? Well, let's see. 4 times 1 is 4. 4 times 2 is 8. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is, ooh, there we go, 20. 5 times 4, 4 times 5 is 20. 20 minus 20 is 0, nothing left. So this is what a quarter note looks like in decimal form. Okay, let's move on to our 1/8 notes. Let's take the numerator 1, put it into decimal form, 1.0. I'm going to go ahead right now, in fact, and just bring my decimal up. And then divide it by our denominator, 8. 8 fits into 1 how many times? 0 times. 0 times 8 is 0. 1 minus 0 is 1. Bring that 0 down. 8 fits into 10 how many times? 8 times 1 is 8. 8 times 2 is 16. Oh, that's too many. So it fits into 10 one time. 1 times 8 is 8. 10 minus 8 is 2. Add a 0 here. Bring it down. How many times can 8 fit into 20? Let's see. 8 times 1 is 8. 8 times 2, 16. 8 times 3, 24. Oh, 3 is too many. So 2. 2 times 8, 16. 20 minus 16 is 4. Add a 0 here. Bring the 0 down. 8 times 1 is 8. 8 times 2 is 16. 8 times 3 is 24. 8 times 4 is 32. 8 times 5, oh, there we go. 8 times 5 is 40. 40 minus 40 is 0. I'm left with nothing. So this is what it looks like in decimal form. Let's move over to our 1/16 note. Okay, 1/16 note. Take the numerator 1, make it into decimal form, 1.0, and divide by the denominator, 16. How many times can 16 go into 1? No times. Remember to bring that decimal up, hold its place. 0 times 16 is 0. 1 minus 0 is 1, excuse me. Bring that 0 down. How many times can 16 go into 10? It can't go any times because 10 is smaller. So adding a 0 here. 0 times 16, 0. 10 minus 0 is 10. Add another 0, bring it down. Whew, I got a big number here. 100. How many times can 16 go into 100? Well, 16 is a bigger number because we now have not only the ones place, but we also have the tens place here. So my number 16 is a lot bigger to multiply. So what I think I'm gonna do is, let's see if I can make it easier on myself. I could use a calculator, but I'm too smart to do that. I don't need a calculator. I can show it by breaking up 16 and making that into numbers that are easier to work with. So the way that I could do that is like this. We already know 16 times 1, that's super easy. Anything times 1 is itself, 16. 16 times 2. Well, I might not know what that is off the top of my head. So remember, I said we could break up 16. I haven't even been showing you this. Oh no, let's just go back and review because I forgot to make sure that you could see my whole page in the camera. So remember, we went to 1, the numerator, made it in a decimal form, divided it by the denominator, 16. 16 can go into 1 0 times. 0 times 16 is 0. 1 minus 0 is 1. Bring that 0 down. 16 goes into 10 0 times. 0 times 16 is 0. I'm left with 10. Added a 0 here. Bring it down. Now I have that 100. So sorry, scholars. Okay, going back to our multiplication. We're trying to see how many 16s can fit into 100. So, we're on 16 times 2. We can break up 16 into something smaller that it's easier to work with. So I know I could break it up into 10 plus 6. Those are smaller numbers. Put it in my parentheses. Times 2. And then I'm going to use the distributive property. 2 times 6 is 12. 2 times 10 is 20. 20 plus 12. 0 plus 2 is 2. 2 plus 1 is 3. 32. Okay, 16 times 2, 32. Well, 32 is still pretty small. We're trying to get to 100, so let's keep going. What about 16 times 3? Break 16 up into something smaller. 10 plus 6, parentheses, times 3, in the distributive property, sorry. 3 times 6 is 18. 3 times 10 is 30. 30 plus 18. 8 plus 0 is 8. 3 plus 1 is 4. Equals 48. That's still a really small number, trying to get to 100. Let's go 16 times 4. Break 16 up into 10 plus 16 times 4, distributive property. 4 times 6, 24. 4 times 10, 40. 40 plus 24, 4 plus 0 is 4. 4 plus 2 is 6. Equals 64. Whew. We're getting closer, but we're still trying to get to 100. And 64 is not quite there yet. Let's try 16 times 5. Break that up. 10 plus 6 times 5. And distributive property. 6 times 5 is 30. 5 times 10 is 50. 50 plus 30 is 80. Whew, we're getting close. Let's see if we can get it into 16 into 100 6 times. So let's go 16 times 6. So break this up. 10 plus 6. It's easier numbers to work with. Times 6. Use my distributive property. 6 times 6 is 36. 6 times 10 is 60. 60 plus 36. 6 plus 0 is 6. 6 plus 3 is 9. Ooh, 96. I'm getting super close. I wonder if I can fit one more 16. Let's try it. 16 times 7. 10 plus 6 times 7. Distributive property. 6 times 7, 42. 7 times 10, 70. 70 plus 42. Let's see. 0 plus 2, 2. 7 plus 4, 11. Too much. So we're going to go with 6. 16 can fit into 100 6 times, and it is 96. 6 times 16 is 96. 100 minus 96 is 4. Add a 0. Bring it down. Okay, can 16 go into 40? It sure can, because 40 is bigger than 16. Let's see how many times. Well, I already did a bunch of different multiplication with 16 already, so I'm just going to use what I already did. Starting from 16 times 1. Easy, 16, yep. What about 16 times 2? 32? Yep, we're looking for 40. 32 is less than 40. What about 3? 48. Nope, too much. So 16 fits into 40 2 times. And 16 times 2 is 32. 40 minus 32. I'm doing it in my head. I know it's 8, but I'll show you how you can do it if you don't know how. Hopefully you do. So I have 0 here, so I need to borrow from this 4. I'll make that a 3. And I'm borrowing 1 to make 10. 10 minus 2, 8. 3 minus 3, 0. All right, so 40 minus 32 is 8. Add a 0. Bring it down. Can 16 go into 80? Well, it sure can, because 80 is bigger. So let's use all those multiplication problems that we already did to find how many times 16 can go into 80. 16 times 1, 16. Times 2, 32. Times 3, 48. Times 4, 64. Times 5, oh, here we go, 80. That's what I'm looking for. So 16 times 5 is 80. 80 minus 80 is 0. We're left with nothing else. So guess what? This is what 1/16 note looks like in decimal form. Whew, that was a lot of math, Miss Stone. That was a lot of work. You know what? It was, but I enjoy it. It's therapeutic to me. I love numbers. Okay, so let's go ahead now and put these decimals into a whole measure. So if we were right in our long division and all of the other types of mathematical things we did, like addition and subtraction and multiplication, then we should be able to write up a measure that has parts that equal a whole. So I'm going to use the rhythm that we created for our fraction bars and pie graphs to see if I can get my decimals in parts, add them up, and equal one whole. So the first measure, I'm looking for a quarter note. A quarter note in decimal form is 0.25. So let's write that, 0.25, that's my quarter note. Plus, I have an eighth note pair. All right, an eighth note pair. So I know that 1/8 note is 0.125. So I need a pair, so I'm gonna have to add that 2 times. 0.125 plus 0.125. Okay, there's my eighth note pair. And then let's see, beat 3 of my measure was another quarter note. Again, 0.25 plus, and the last beat, beat number 4 in measure 1 was another quarter note, 0.25. All of these parts should equal 1 whole if I add them. So let's see if I can get 1 whole by adding all these parts. Get your scratch paper. Here we go. 0.25 plus 0.125. Well, you know what? Miss Stone needs to make sure that she lines up every single place in the right spot. So I'll line up. Here is my ones place. Here is my tenths place, 1. Here is my hundredths place, 2. And here is my thousandths place, 5. All right, 0.125 plus 0.25 and 0.25. Well, I'm noticing that 0.25, I've only got my tenths and my hundredths place. And these are, I've got all the way up to thousandths place. So guess what? I want to make them all look like they're all thousandths, so it's easier to add. So I can just add a 0 here, and a 0 here, and a 0 here to the thousandths place. Because I'm really adding nothing, I'm just holding that place open. It's still 0.25, right? 0 means nothing. Okay, now let's add this all together. Here we go. I've got 2 5s here. Let's make it easier on myself and say 5 times 2. I know that is 10. 10 plus 0 is 10. So here we go. 0 on the bottom, the 1 on the top. Okay, I've got 0.25, well, let's start over. I've got a 5 here, a 2, a 2, a 5, and a 5. Well, I've got 3 5s, so let's make it easier on myself and say 5 times 1, 2, 3. 5 times 3 is 15. And then I've got 2 2s here, so let's go ahead and make that easier on myself and say 2 times 2 is 4. So we had 15 plus 4, that's 19, plus that 1 from the 10 here, that's 20. 2 at the top. Okay, let's look here. Do I have anything I can group and make easier? I sure do. I've got 3 2s. 1, 2, 3. So, and I actually have 4 because I'm adding 2 from this part, the 20. So 1, 2, 3, 4. Great, so 2 times 1, 2, 3, 4. 2 times 4 is 8. 8 plus 1, 2 is 10. All right, here we go. 1 plus 1, 2, 3, 4, 5 zeros is still 1. And remember to bring down that decimal. And guess what? All those parts, they did equal a whole. Measure number 2. Let's try it out. My second measure. The second measure looks like this. 4/16 notes to equal 1 beat. My second beat was a quarter, and then beats 3 and 4, because remember this is 2 beats, is my half note. So let's go ahead and start by adding all these parts to see if we can get 1 whole. So 1/16 note I know is 0.0625. But I need 4 of those to equal 1 beat, so I'm going to add that 4 times. 0.0625, 0.0625, and one more 0.0625. Whew, it's a lot. There's my 16th notes in 1 beat. The next part of the measure I already told you was a quarter note. Beat 2 was a quarter. So plus 0.25. And then the last part of the measure was a half note, beats 3 and 4, gets 2 beats. And it looks like that, 0.5. All right, these should all equal 1. So let's go ahead and see if that's true. Get your scratch paper. 0.0625, 0.0625, 0.0625, 0.0625. Whew, it's a lot. Plus 0.25 plus 0.5. All right, so I'm going to add 2 zeros to this one to make it to the 10th, 100,000th, 100,000th place. And I'm going to add 1, 2, 3 zeros to also get there so we all can look the same. All right, let's group these 5s together. 1, 2, 3, 4. 5 times 4 is 20. And we just have 0, so nothing else is left to add. 0 here, 20. Okay, let's see about this one. We've got 2 times 1, 2, 3, 4, 5. 2 times 5 I know is 10, and we've got nothing left to add, so 10. Okay, I've got a bunch of 6s here. Let's see. 6 times 1, 2, 3, 4. 6 times 4 is 24. Plus 5 is 29. Plus 1 is 30. And 3 up there. Okay, 2 and 5 is 7. 0, 0, 0, 0, 0, and 3. So 7 plus 3 is 10. Bring down that decimal. 1 plus 0, 0, 0, 1 plus nothing is 1. So yes, I do have 1 whole. Okay, measure 2 does work. Measure 3. Say measure 3. Let's look at it. We got 2 eighth note pairs, a quarter, and another eighth note pair. So remember, I've got to add 0.125 2 times to get 2 eighth notes, or an eighth note pair. 0.125 plus 0.125, there's my eighth note pair. Another set of eighth note pairs. 0.125 plus 0.125, okay. Plus I had a quarter, 0.25 plus another eighth note pair. 0.125 plus 0.125 should all equal 1 whole. 1 whole. All right, here we go. Let's add it all up and see if we're right. So 0.125 plus 0.125 plus 0.125 plus 0.125, because those are my 2 eighth note pairs. And quarter note, 0.25, and another eighth note pair, 0.125, 0.125. Okay, I need to add a 0, right? Okay, here we go. Plus, I've got 1, 2, 3, 4, 5, 6 5s. Whew, and 1 0. So that is 30. Let's see, I got a bunch of 2s. Let's group those together and multiply. 2 times 1, 2, 3, 4, 5, 6. 2 times 6 is 12. 12 plus 5, 17. 17 plus 3, 18, 19, 20. Okie dokie. Let's see what I got here. I've got a bunch of 1s. So let's go ahead and add them. 1 plus 1, that's 2. Plus 1 is 3, 4, 5, 6. 6 plus 2 is 8. 7, 8, 9, 10. I've got 10. Bring down my decimal. 1 plus all those zeros still is 1. And guess what? Yep. All those parts did equal 1 whole. And we're on to our last measure. Say, hooray, our last measure. I'm super excited. Measure 4. Okay. Well, I've got a half note. So I know I'm going to be writing 0.5 plus quarter note, and a quarter note for beat 3 and 4. 0.25 plus 0.25 should all equal 1. Let's do the math and see if we're right. 0.5 plus 0.25 plus 0.25. We'll add a 0 here to the hundredths place because we have hundredths right there. Okay, 5 plus 5 is 10. And 2 plus 2 is 4. 4 plus 5 is 9. Plus 1 is 10. Bring down my decimal. 1 plus 0 is 1. Yes, we did that. All those parts equal 1 whole. Yes, so now we can clap the rhythm. Okay, so I know that 0.25 is a quarter. 0.125 is an eighth note. 2 of them together is a pair. So, quarter, quarter. Let's try measure 1. Measure 1 sounds like this. 1, 2, here I go. All right, I've got, if you want to, because it's hard to show with numbers to look and see what notes you got there, you can just put it down below. Okay, so I've got 1, 2, and 3, 4. Let's see what I got here. Looks like this is my 16th notes. I'm making that super big. They don't normally look that stretched out, but I got lots of numbers there. 1 E and a. 2, 3 E. 1 E and a 2, 3 E. Okay, then I've got my eighth note pairs again. Eighth note pairs again. Quarter. Eighth note pair. 1 and 2 and 3, 4 and. All right, measure 4. I've got my half note, my quarter, and my quarter. 1, 3, 4. Let's put it all together and clap the rhythm. We're using numbers, remember? 1, 2, here we go. 1, 2, and 3, 4. 1 E and a 2, 3 E. 1 and 2 and 3, 4 and 1, 3, 4. There is our measure written out into decimals. Thank you, scholars. Your turn. I hope you had fun learning how you can put these different notes that are part of a rhythm and a measure into decimals. See you again next time. We're going to do something else.